Okay.
Okay, go ahead, Sean.
All right, in this demonstration, we'll begin with the thought of working on some architectural submittals. Just real briefly, just tell it that we want to insert some walls, and we'll give particular walls some sort of dimensions. So here in AutoCAD, I can select any position that I'd want to get started, and then type any dimensions. For example, 120 for the first wall, and we'll put 144 for the second. I'll hit enter a second time whenever I'm done placing walls. Of course, you can add additional openings, make walls follow polylines, whatever it is that you want to do. Working from our library of products, we just begin by selecting product, in this case a two-door base, and I'll select on a wall where we might want to be able to place the product. Notice how easily it can slide into any position or even change directions along an opposing wall. We just give this an insertion point that we want it to work with, and I'll select the multiple button in case we want to be able to put in more than one of the same product. In this case, when you select an object such as a cabinet, it gives you the ability to place it to the left, to the right, to the front, to the back, to the top or bottom of it. In this case, we'll place it to the right of it, and I'll hit the checkbox, which will end that command. Just moving on to some other items within the library. If I want to be able to place additional products, I no longer have to work directly with the walls. I can select the objects as well, and we'll tell it that we want to be able to place it to the right of this item as well. I'll go ahead and, in this particular case, go to some upper cabinets, and let's say that I want to be able to place a two-door upper. Again, we can select walls, positions, whatever it is that we want to do in order to be able to easily and quickly be able to place products. Just for the sake of getting a little bit more data into this, we'll go ahead and tell this that we want to put in some items. For example, here's a two-door, one-drawer cabinet. This time I'm going to select a wall that I might want to place on the opposite side. Notice that the original snap positions was in the back, left, rear, which was great working with the other wall, but in this case that would be a little bit more difficult. Of course, I could eyeball it to get it close, or I could know distances and types and things, but notice in AutoCAD Cim that I also have the ability to change my insertion points. I could move it to the fronts, up above, below, or whatever, and so if I just click this, then of course I've got a nice easy way to be able to quickly place products as well. And again, I'll just put in a second one of these. And so now I'll place this over to the left of this product, and we'll say okay. Now we could go ahead and we could put molding in it, countertops, or continue adding products, but for the initial purpose of the demonstration, I want you to see what it would be like if we were going to generate the architectural submittals. And so I'm going to tell this that I want to work from a 2D plan, and we'll tell this to process both of the walls and all the cabinets on this. This is going to generate not only a 2D plan that's proper for the way that we'd expect for an architectural submittal, but it's also going to do all of the work in changing the AutoCAD views for us so that we don't have much heavy lifting in AutoCAD. Now we have that, we can decide where we want to place that, above, below, beside, whatever it is that we want to do. And so the final thing that I'll do is tell this that I want to go ahead and label that plan view. You'll see that we've got nice hatching and super clean lines and stuff done for this. Let's say that I want to create, for example, an elevation. I'm going to just select on this, and I'll say, hey, I want to point this elevation. I can go in any direction, but I want to point it towards the first elevation that we made on the north wall. And so now it's going to process all of the data for us to give us the proper appearance of things. You might notice even in the 2D, as you're looking at this, you'll see that even the 3D, the 3mm edge banding is being drawn. It's just super, super clean for the way that you would expect this. I'll go ahead and place this elevation and give this, tell this that I want to label this view as well. Just for the sake of it, let's go ahead and do the other elevation as well. And so we'll tell this that we want him to place here. And so now we've created a second set of elevations. And so again, these could be placed anywhere that you might want within your drawing. Maybe while we're here, we want to create a section. And so in this case, I'll just say that I want to section these two products. And so I'll pick a point on this and a second point in here, and we'll tell this that we want to pick a point here, and we'll label it A. So it's automatically going to do the work to provide us with a live section of the product as well. And we'll go ahead and label this section while we're at it. Other things that we might want to do while we're getting this done is we'll select that we want to go ahead and dimension these out. So I've now dimensioned both of the elevations as well as the floor plan for this. And we'll go ahead, excuse my coughing, go ahead and dimension the sections as well. If you want to see that into a paper space kind of an environment, really easy to do. I can just work within any one of these and to be able to say that I want to link a view to these. So in this case, we'll tell this that we want it to be the plan view. We'll come down here and say we want to link this. And I want this to be one of the elevation views, and we'll make this the first elevation. Work into this view, link this, tell this that I want it to be the second elevation, and finally I'll work over here and tell this that I want to link this to the section view. That was done, so everything's properly labeled and complete. So you can do very, very fast and detailed architectural submittals. Roger, I believe as part of this demonstration, one of the things that we wanted to do was to add a number of additional products to this, and so we could really do that in any kind of a way. Also note that you can place these out in space if you like, and to be able to say that you want to be able to put in multiples of these with this same method that I showed you earlier. If I wanted to just do that occasionally, one or two, or I would have the ability, if I highlight this button and say I want to push the quick insert button, in this case we'll tell this that we want to put in some two-drawer cabinets. I'm now going to give this quick placement, so literally it's just as fast as you can hit the button to be able to repeat the commands for whichever items now that you select. It's going to place it, and so I could just keep going down a list and picking not only this product, but I could also select additional products as we're moving across. So I'll just say I want to go, and now you'll see that these are placing exactly the way we told them to place. Let's put a one door in, and let's go ahead and throw a tall unit in. Back to base cabinets. And again, this is just because I didn't have a purposeful elevations or rooms that I needed specifically to fill. And so we would be adding those kind of things, however it is that we want. And of course, we could build custom items the same kind of way, but just wanted to get enough products within the job to satisfy the requirement. I don't have an exact count on what we're doing here, but I'll let Roger just kind of jump in and tell me when he feels like we've got enough products in the job to do a reasonable test.
I think you got enough there to go ahead and shift over to Router Cim.
Okay.
And show it. If they want more, we can do more.
Yeah, absolutely. So here is basically what I would have to do in this case. I would click on the system and I'd say save order as, and in this case I'll just call this Roger, and I'm going to tell this that I want to automatically generate the programs. And so what I'm actually doing at this point is generating DXF for each individual part within this, and in this case I'm not filtering anything else. So it's actually every single part being sent over to Router Cim, and I'm also sending a corresponding CSV file that is going to give the remainder of information that wouldn't be contained in the DXF to Router Cim, such as edge banding, part information, the kind of stuff that you would expect to be able to see across on a label for each of the parts.
So basically what you've done is you've pressed one button after you've done the drafting, and that one button is generating a DXF file for all of the parts in this job and a spreadsheet that relates to each part in terms of edge banding and material information.
Yeah, absolutely. And we'll see that we've processed roughly it looked like in the counting 300, almost 400 parts in that length of time. So anyway, I'll close down AutoCAD Cam at this point. One thing I might do, if you want, I'll just poke open just a couple of DXF files so that you can see what's going on, and then we'll fire Router Cim. This isn't a step that's necessary to process them, but just to see what it is that we're starting with. And so those would have been placed in a file location that I just made it C, and then I made a folder called Router Cim. And so here we would see that we have a CSV file that is, you know, Roger here, so we can look at the things in that, or we have this that contains all of the DXF files. So you can see that we made 342 of them, and if you wanted to see any one of them just for the sake of being able to see, you'll notice that all the holes and stuff are here. We've even over-traveled on the grooves. If you wanted to look at it from, you know, a standpoint of 3D kind of stuff, I'll flip this over and you can see it in like a Southwest view. So all of the machining and stuff has been completed for the parts, and so that's contained within these. So anyway, that's all that I want to show you. There's a whole bunch of them we could look at. I'll fire up the Router Cim automation suite.
I can't believe you have that in the backyard there. That's amazing. You got a lake, ocean view, huh, Sean?
An ocean view. My wife and I recently went to Jamaica, and that was it wasn't technically a view that we took, but it was just an image that I had of it that was fairly close. Okay, so this is fired up, and there's not many buttons that you need to push. We just go to the import wizard and say Excel, Delimited Import Wizard version 2. Actually, for most people, they wouldn't even have 2 versions of it. And so I could literally just go select the CSV file that I want, and we named that Roger. So I'll select it, and now we'll see that it's brought in all of the parts and pieces that are here. It's got all the information and stuff for them, all the materials, everything else. You just choose the strategy. In my case, I have more than one strategy, so that's the only difference. You wouldn't have to do that. And I will click import. And if it does find, in this particular case, that you have any materials that were not resident within the Router Cim library, it tells you, hey, I got this, what do you want to make it? So in this case, there'll probably be a couple, so I could either go select from a material from the library, or I could create a new material. It gave me the file for it, so it made it really easy to be able to do that. So all the parts and pieces and everything are here, and so the final button that I would click on is Run Job. And so now it's going to fire up its own version of AutoCAD session, and it's going to start analyzing all the DXF files and processing them, and then we'll generate the nest files and G-code as well. So I'm not sure exactly what you'll see on your screen being GoToMeeting for the way that it records, but what I'll see on my side, and you'll have to verify, is that I'll start seeing in just a moment each of the parts as they pull up to process. So there was the first one, and so it takes just a few seconds per part to be able to do all the analyzation for these. And a couple of end panels and doors, and of course the stretchers and nailers, shelves, backs. Router Cim does take a few minutes to be able to process this kind of number of cabinets, but real time saving comes in the fact that it nests so amazingly that you don't spend any time editing the nests. When I look at their nest patterns, they're just so much better than other nesting algorithms I've seen that it's not even funny. That translates not only to a significant amount of time savings in editing nests, but also tremendous improvements to yield compared against some other softwares. I've heard some numbers that are almost too hard, hard to be true, but I've gotten them directly from customers doing exact studies on materials, so I know it's accurate. Not only does it do that, but it's also its algorithms for how it approaches parts and runs code to the machine often results in it producing nests that have machine cycle times 20 or more % less than other CAD/CAM softwares as well. So it may be a little bit hard in this case to just sit back and watch each part come across the screen for this number of parts, but it certainly does a great job. If I were running this in a production environment and doing a fair amount of this kind of stuff, I probably would have a secondary machine tied to the network and let it be processing like this while I was working on a second PC. I could continue to be doing work on this PC, but of course, it's trying to use as many resources as it can to move as fast as possible.
What kind of machine are you running there, Sean?
Actually, I'm just running a Toshiba laptop. It's nothing special. It's probably close to 3 years old, maybe 2.5 years old. And it's got like 8 gig of RAM on it. Got a 1 gig video card on it. It's about time for it to get replaced for sure. But anyway, I think it would be good for as cheap as it is to get a additional PC to have it so that you're just able to go directly back to work for more engineering or other CAM processing on a secondary machine.
So the way you see it is that you would design and then put it onto the network and then go to the other machine and pull it off of the network and then flush it, have it processed while you're doing more design work on the original computer.
Yeah, in this case with Router Cim, it's not typically, let's say that you had 4 engineers working on something. It's not typically 4 different people processing through Router Cim anyway. It's typically 1 person that's doing that kind of work. And so, of course, you would just make your directory folders automatically coming out of WCAD-CAM, be able to hit someplace accessible by all the computers. And so the person at Router Cim would be responsible to go grab the next batch and the next batch. It's, again, not very many buttons. Most of the work that's being done is automated and being done behind the scenes. It's just that it does, process all these kind of things to make sure that it gets every bit of information and does it very well.
Yeah, I've had people tell me that they don't have a problem with it taking so long. I think it takes a long time, but the problem is that, the opportunity is they're saving between 10 and 15% of their raw material, and some of these guys are putting up $100 sheets. So, I've done comparison analysis with Router Cim versus others, and 15% is not unusual. 15%, and in addition to that, you literally save, you do 9 hours of work in 8 hours with this software. We have other videos that'll go into more details about Router Cim, but it's the most expensive to buy and the cheapest to own because it pays so much money back to you, and not just in raw material savings, but also in terms of tooling, because they have some strategies within their software that does stay down routing, common line count is also available. Circumstances arise, but with stay down technology, Router Cim reports that they will cut the tool time or the tool path will be 20% less using stay down technology. So I'd say
that's true, because in traditional nesting, the router is going to go plunge into a part, route around it, and then it's going to exit the part, come zing up, and it's going to move to a new position, plunge into a part, so zing up and zing down. So all that time that's occurring, plus, when you're already in the wood, just continue cutting at the regular feed rate onto the next part. So that's definitely something that makes sense.
I wonder how many parts we've gone through. Is there any way of saying that, Sean?
I don't think at this point, until it's in a further process. Oh, actually, so I can see that we're at 6 minutes and 58 seconds, and it's working on the 154th part. So I think that we had a total of, if I recall, 342 parts. So we're almost at the halfway point.
I think what I will do is stop the recording and then restart it up, and hopefully it'll conjoin the two together. We know that it's going to take...
It does not do that. Oh, yeah.
Oh, it makes separate?
That's right.
Okay, I won't do it then. We'll just run it through and then have... Yes, what it's going to amount to is about 14 minutes of Router Cim calculations. After it gets all of these DXF single parts done, it doesn't take that long to do the nest, does it?
No, this is the part that takes the longest. I think you can see, just kind of as these are flashing up on the screen, even though you don't have full view of what you're seeing over on the left-hand side. Each time you see one of these, you're looking at somewhere around 2 seconds or so apart, and that's obviously a lot faster than it's going to process on the machine, but that's about the time. So without doing a whole lot of math, you can quickly figure out that you're somewhere around 15 or so minutes for that size of a project.
What other features can you think of about Router Cim that makes it such a important player in the woodworking industry, Sean?
Oh, I think for pretty much, first of all, that you want out of a can, you want to be able to push anything that you want through it. And so whether it's analyzing a solid model coming from, any other software, whether AutoCAD, Inventor, SolidWorks, Pro-E, whatever it is, it has the ability to analyze and process those, models that were created as well. I think that it's really important. We talked about the material savings, and we talked about the speed, that it reduces the machine cycle times. But a couple of things we didn't really talk about. One is it's got one of the most powerful true shape nesting algorithms that I've ever seen. Nesting parts within parts. I mean, you just look at it, and there's no way that you can figure out some other way to place it. And at least a vast number of our customers, especially those in store pictures, the commercial market, are doing a fair amount of work that's not just rectangular. And in their cases, they've spent a huge amount of time trying to get that stuff out to the machine and done well, where this will automatically process those, and coupled with WoodCAD CAM, that gives you a huge amount of power on the creation of custom things. That works out good. One other thing that I think is really unique is that my customers started telling me how much tool life improvement that they got. As you can imagine, all the plunging and in and outs and all that kind of stuff is, I won't say harmful to the tools, but it definitely is creating heat, friction, and wearing out the carbide tools. So, they're telling me that they're, number of sheets that they're going through with the same tools goes up tremendously. And if you spend much time looking at the prices of solid carbide, helical ground, compression spiral, bits, I mean, they're not cheap. I'm spending $50, $60 a bit. If I can, increase the number of sheets that I'm getting by even 25, 30%, that over a period of time becomes a huge amount of money. And so that's good. Something else that you'll see, well, actually, I'm not sure that you'll see a lot of it, but it's just happening for you, is that it's also dealing with off-all. And so where you have a situation that is, scrap could be saved and reused, especially when you're talking about sheets that are very expensive. It's got the ability to do those kind of things. You can add new sheet sizes and stuff on the fly very quickly. And I don't know, it just works. I mean, that's what these guys have been doing for a long time. They, as probably everybody knows, they were part of the Como group, and that's what, if you ever spoke to the Como salesmen over a vast number of years, they did more selling on Router Cim than they did their routers. The rest of it was chunks of steel and some drives and parts and, those kind of things. It was the software that really separated and made Como one of the top selling routers in the world. And then when Frank Rubino bought the Router Cim back out of it, Como still uses Router Cim. As a matter of fact, several others do. I mean, you order a CNC machine from several brands, and it used to be several years ago, everything came with AlphaCam. Today, now there's an opportunity, especially for those using AutoCAD, to be able to say, no, I want to be able to put Router Cim with this, just for the familiarity of AutoCAD, but also the power that the software has. You're right, it's not an inexpensive software, but what it does is pretty much unlike anything else on the market.
It's one of those products that it costs a lot to own, but it costs even more if you don't own it. And that's a kind of a painful reality for a lot of people. But the bottom line is that it's a mathematical equation. And I mean, I've done studies and gone to leasing companies, and I'm coming out with, hey, you're getting a return on your investment of 7 times your monthly payment, 700% a month. So if my monthly payment on this is $700, I'm telling you, a month you save $4,900, and that sounds like that's a lot of money.
Some of the numbers seem like it doesn't make sense, but I had one of my customers that his name's Kent Swenson from Timberline Cabinetry and Millwork. He's out of Kansas, Manhattan, Kansas, and he did an analyzation. I'll flip this over so you can see what's happening just for a moment. Okay, how do I do this? Okay, now I can see it. I just wanted you to be able to see what was happening on the screen as the nests were being produced. Not a big deal, but it was laying out all the parts and pieces, and there they are in AutoCAD, taking the entries and toolpaths and those kind of things are being generated for it. Anyway, Kent told me that he did an analyzation compared to another software. In this case, it was Microvellum, and he believed that Router Cim running his production would make a difference of $150,000 a year for his operation, and they do just under $5 million in business. So, yeah, it's not a cheap software, but if it gives you back the return multi-times its value in the first year, it's probably a worthwhile software to consider.
So basically, it's going all the way through.
Yeah.
I guess we don't know how many materials were in that job.
That's the one thing I could have, if we wanted to make this demo seem faster or better or whatever, I could have reduced it down to just a couple materials and tried to make it look good, but I use this as kind of a real world situation to where lots of our customers have different thicknesses, different grades, and different materials with each one. So anyway, and then at the end of what it's doing, when this is finished with all of the, you'll notice that it's making matches for labels and all that kind of stuff, so that everything is going to be done.
Are you aware of the capability of Router Cim to control the number of articles coming off of the router at one time? So let's say you have 4 or 5 different stacking units with rollers. You can tell it, hey, I only want 4 or 5 coming, and I want it to come from this range of jobs, and it'll actually create a flow of process where you don't spread out your parts from too many different boxes. And you can actually set the... Go ahead. Go ahead, Sean.
A lot of parts. Yeah, it's nice to throw a lot of parts at the algorithm so that it does a better job of nesting, of course. But if you get very many of them, you've got this whole glob of parts trying to make their way down lines, and you got to have all the parts of a product to be able to assemble it. So those kind of controls are very powerful. There's just so many features of Router Cim. I mean, that's the business that these guys have been in for 20 years. Is figuring out what they can do to provide and produce the most powerful CAM and nesting, engines out there.
Yeah.
You might find something cheaper, but you don't find somebody that beats the results. So it did complete. Process has been completed. It was, right at 18 minutes for the total time. What this does automatically for you at the end of it, just in case you want to be able to go view results, as it pops open the results folder. Here's the nested DXF. So you wanted to know, what did we have for different materials? You can see these, and so, if we wanted to click on one of these, here's the white melamine 2 side. You could pop open and view in CAD, whatever it is. So here's all the different nests and stuff laid out, all their stuff ready for plotting stuff. So it does just a super good job of making sure that it's utilizing all the materials and those kind of things as it's made its way across.
Yeah, I know it can flip between multiple sizes and scrap too. Sean, is the G code already made for these nests now?
It would have already happened. In my case, I'm not running to a particular machine, so I'm not making a version of code, but that was just a text file, so that was just a super fast. So each one of the nests would have their own text file associated. When we looked at the results area, if we were back at this job, that's exactly what we would see, as we would have the files for those. So
okay,
they can be out files in some cases, they can be .cnc files, they can be a bunch of different things. So it's really a matter of whatever it is that you would want to be running in this case. So I think if I view this and through a notepad, you'll see here's G code that's written. I'm just not making, I just didn't set up for, what I'm saying is for your customers, specific ones. So I'm calling out based on my,
right.
my setup.
But the time it took, those 18 minutes, we actually, in a real world situation, we would have generated G code for specific machine tools.
Yeah, so I mean, this technically you could call this G code. I made files for each one of the, so there's code for each one of them. It's not that there's not code written. It's just that I didn't set up anything specific to have customer tool numbers and all that kind of stuff for it.
Yeah, it's not expected. Okay.
Yeah.
All right, sir. I really appreciate your time, Sean, and I will wrap this up and get it recorded.
All right, see you, man. Bye.
Thanks.